But you should expect calculation questions to come from the monopoly session, a little bit about energy efficiency session, and for auto evaluation session, there could be numerical questions that's going to be tested. I think I've sent you basically you have the problem sets 3. If you have questions on that, I will give you answers. I will give you guidelines on answers, not detailed explanation, but guidelines on answers. We discussed a few simple questions. I have 2 simple questions in this class, so if we have another 20 minutes at the end of the class, we can go through that. So that should be enough for you in preparation for the exam. I will not distribute more questions. So the simple questions that I presented in class, I will upload them online. I think I haven't done that yet, but I will upload that to Canvas after the conclusion of the whole class. Any further questions?
The exam is supposed. Sorry.
No, go ahead.
Sorry, the exam is supposed to be next Tuesday, correct?
I haven't checked the date. Should be, right? Should be.
Yeah, I think it is next Tuesday.
Yes. Okay.
And then, oh, sorry. Go ahead.
sorry. Because we have 2 still Zoom meetings set. So after that, is any plan for lessons after the final? I mean, why do we have lessons at 2nd of June? Something like that.
No. Don't just ignore the Canvas. I just picked like 15 classes when I first said it. So ignore we don't have any further classes. Let's say I will give you guidelines for you to follow what session should you choose for the exam.
Wow. Last thing was the second part starts from the methods. It does include also hotel role, because I didn't listen properly. The hotel role and the resources.
Yes. So anything after that, so basically after the midterm, we had method, we have evaluation, monopoly, efficiency, climate change. That's pretty much it.
Okay.
And then just a clarification from me. I know with our midterm, you're maybe a little bit concerned since it was, first online exam about cheating and stuff like that. So I think you extended the questions just so we would use the full time allotment. I think a lot of us were kind of like racing to finish a little bit towards the end there of our midterm. I was wondering if you were going to have a similar approach for our final.
I think so. You will find, like, if you know how to do these questions, you will find you should be, maybe you have 10 minutes left after the exam.
Okay.
But if you need to think very hard or you need to go through the notes extensively, you might find kind of the time a little bit pressing.
Gotcha.
The purpose is just try to avoid giving you too much time to think about other things. So I think it's okay if basically that's a role applied to everyone.
Okay.
So you need to plan about your time as well. Like if you make sure that you answer all the questions you know, and use the rest of the time to think about more challenging questions.
Gotcha. Okay. Thanks.
About the time, I would like to have a bit more time to upload the pictures because I don't know. For me, I write extensively, so it took me too much time to scan all the stuff, and I didn't make it in 5 minutes because I had problems with uploading process.
Yes. Yeah. I can give you more time. So basically, the updated rule would have it that at the end of the exam, you are going to show your exam papers to the camera, or basically just show them to the camera. And then I will give you more time to upload. So if I find discrepancy between the thing you uploaded and the thing you scanned in front of the camera, then that's a problem. So because one of our colleagues said that what if someone took the Zoom exam and someone else uploaded another set of answer, and like, well, so basically I'll give you maybe 10 minutes. Would that be enough? For uploading, for scanning and uploading. But before that, maybe another 2 minutes for you to just show me your exam papers in front of the camera. Yes.
Yeah, thank you.
If we don't have further questions, let's start with today's course materials. Climate change, that's probably the reason a lot of people are taking this course. It's the most important topic in this field of environmental economics. And it's the most one of the most important global challenges today. So to start, like I'm sure that none of you are climate change denials. But in case you encounter this kind of people in real life, how would you persuade someone that climate change is real and it's due to human activities?
Science.
Yes. I guess there are a lot of. I'm putting up some figures to help you. So basically, this was a study on the concentration of carbon dioxide in the last 10,000 years, based on some specific kind of geological studies on certain locations. And you can see the levels of carbon dioxide have been kept pretty stable over time until the 19th century, which we believe was the time of industrial revolution, and it pretty much skyrocketed over time. It coincided with temperature. Basically, after the 19th century, the temperature also started to rise. As you can see, there are different measures of temperature. You can measure this scientifically using thermometers, but for more ancient history, you need to rely on two readings, ice cores and historical records for that. But basically, those measures were consistently pointing to the view that the temperature is rising pretty fastly in the recent 2 centuries, which pretty much coincide both in time and trend with the concentration of carbon dioxide. And we believe that we have good explanations for that scientifically. The size of emissions, to date, about 80% reporting. To date, about 80% of all greenhouse gases have been emitted by the richest 20% of the world population. But we would expect the trend to the trend might be accelerating as the developing world becomes richer over time. The poorer countries, less developed countries, when they industrialize, the level of carbon emission is going to raise pretty fast over time. So it's a matter of how do we work out a solution about mitigation, work out technology about mitigation before the the developing world, the less developed countries, industrialized and has a higher carbon intensity in their daily life. So talking about the impacts of climate change, what kind of impacts of climate change would you think about? These pictures trying to give you basic guidelines. So I think the main effects are twofold or threefold. First is the weather, rising temperature, and increased variability in precipitation. So it's not just about temperature. 10 years ago, we called this global warming. Now it's more like climate change, which includes not just the rise in the mean, but also the rise in variance in both temperature and precipitation. The other group is about sea level rise. So we know ice in both North Pole and South Pole gets melted, and that pushes the sea level rise, which threatens the livelihood of a lot of coastal communities. So these three effects combined together are expected to have all sorts of impacts on different groups of things, starting from health to agricultural production, to forest, to the reproduction of forests, to water resources. Sea level rise threatens coastal areas, erosion of beaches, inundation of coastal lands, maybe increased intensity of coastal weather shocks like typhoons or hurricanes. And combined together, the loss of habitats, the loss of land, and the kind of changing forests will threaten the livelihood of a lot of species as well. But there will be a potential negative biodiversity impact as well. So what else could you think about?
Disease as well. I guess that relates to health. For example, like in some Central African countries, once the temperature rises, the frequency or the conditions that are conducive to spreading malaria starts to increase wider and wider over that country, increasing the incidence rate.
Yes. Yes, it's the infectious diseases, the spread of diseases might also, first, temperature is definitely affecting the spread of infectious diseases. And second, you could imagine diseases usually a secondary impact or some natural disasters like flooding, especially in the West developed world. Sea level rise is associated with a higher frequency of flooding. It might cause some problem that as well. So a lot of these effects are pretty much uncertainty. So we can't really expect we don't even know what the worst case scenario would look like. You can imagine the world is ecology is a pretty complicated system. A little bit we have experienced the damage of infectious diseases. Like imagine the frequency of global infectious diseases just increases as a result of climate change. Although we can't prove that, that's going to be much more damaging than we expected. Apart from the typical things that's the daily temperature, precipitation, things we could think about. So there, I'm collecting some evidence. So the direct impact of say, global warming or temperature change. And it could be on mortality, right? Heat waves would kill people. So this is a figure on daily. It's the estimated impacts of daily temperature on mortality rates in India and in the US. So basically, trying to estimate the impacts of mortality rate responses to temperature across different age groups. So we know that basic heat waves mostly kill vulnerable groups of people, like old people or infants. In this case, these people is trying to get old people. What's your takeaway from this figure?
Honestly, I don't understand. So I mean, zero corresponds to no effect, I suppose.
Yeah, zero. Sorry, here you can imagine this 70 to 74 is base group. So basically, assuming the mortality rate, the temperature mortality rate relationship to be zero here, we compare the mortality rate responses of other age groups. How that's differed. So of course, the mortality rate response of people who are 70 to 74 years of age will not be zero. So imagine this is 0.2. It means that people who are 5 years older are like 10% more likely to die than people in 70 to 74 as a result of temperature regulation.
Is there any reference about the delta T? I mean, what kind of delta of increase of daily temperature causes this increase in mortality? Or you have to read the details in the paper only?
You mean what kind of mechanisms are there?
I'm saying it is increasing 1 degree, and this is the effect of 1 degree increase in the mortality effect. I don't know.
I think it's about 1 degree. I forgot which metric they're using. 1 degree on percentage. So this is a base rate. It doesn't mean that it's zero. It's basically average of 75 to 79. What the impacts on other groups compare.
Okay.
So what can you tell?
Now, I was trying, maybe I don't understand, I mean, if there is, the increase of mortality with respect, it was 1 degree of 2 degrees, and according to the range of population, the different effect, of course, the older the people, the higher the impact, I suppose.
Yes, that's what we expected, right? Like the older you are, the higher the risk factor. So that's the trend you observed using Indian data. So basically, older people in India will more likely to die from temperature from higher temperature. I think I forgot whether or not it's temperature or basically extreme temperature because coldness also kills people. So let's assume it's just temperature and we're talking about heat. But we don't observe in the US the death rate in response to rising temperature is kind of constant across different age groups. How can you reconcile this findings, this difference? How could you explain this difference?
The environment. India is a developing country. It's quite more humid, so maybe the effect of temperature is higher, and there is less. India has a good facility for medicine, I suppose, but many people are poor and much more concentrated, live in lower standard conditions. I mean, this can affect more the mortality.
And maybe they can't really afford AC as well, or fans.
Yes, that's also my expectation. There are just more ways to adapt in the US, like using air conditioning, living indoors is a way to adapt. In India, you expect less of these measures, and maybe the medical system is more developed in the US. That when you kind of contract heat-related disease, you're more likely to be killed than to be cured. So that's mortality. Of course, this is just one paper. There are a lot of papers to study the impacts between the impacts of temperature on mortality across different countries. We don't have identification problem much in this kind of study because they're just you could take temperature as something exogenous. Today just happened to be a hot day, and yesterday, today just more people died, and we can associate the additional deaths potentially to this. There are economic damages as well. There's economic costs as well. This is a figure on agricultural production, modeled change in agricultural production due to climate change over a long period of time. Of course, there are also some papers on this. This is another agricultural study, the model impacts of climate change on agricultural land value over time. I think basically what they had is there are positive impacts for north areas or north of the countries in the north for very cold countries, and within the US there are positive impacts. Basically, here it's the positive impacts countries, counties. Here you have negative impacts counties. So if these places happen to be cold, a rise in temperature help their crops to grow better or help them to plant different types of crops that are that could not have been grown in very cold weather. The effects could be just positive for some countries, but the effects are negative for most of the countries, and especially for most of the countries with high population density, such as India, African countries, Brazil. These are important crop production, agricultural production countries. And if you add things up, it's easy to say that the negative impacts, the negative impacts of rising temperature on hot countries much more outweigh the positive impacts on cold countries. The same thing could be applied to the US. Agricultural land value loss in southern US pretty much much more outweigh the positive impacts in the northern countries, northern counties. So, and another set of outcomes that might interest some people is how would climate change affects human conflicts. So will climate change lead to more civil wars and higher rates of crimes? So this was a nice paper. I encourage you to read that. As you can see, the paper is pretty nice data visualization exercise. So it showed how climate change related weather shocks, rising temperature anomaly, rainfall anomaly, rainfall precipitation variability affects different levels of conflicts. starting from village to country to continental to kind of global scale. So at the village level, there was a study. This is a review paper that collected a lot of evidence. So at village levels, they're pretty much looking at how witch hunting activities in Tanzania. I assume these are pretty kind of primitive villages, primitive communities. And there was anthropology studies that identify a positive relationship between rain deviation. You can imagine how the impacts of rain, how much the rainfall deviates from its original level. You kind of expect the rainfalls to be stable in order to have a good agricultural production. When there is a higher deviation, it disrupts agricultural production. And this paper identified a positive relationship between rainfall deviation and witch hunting activities at village level. So how would you explain this relationship?
Well, it's an hypothesis. I mean, if we start from villages, I mean, the main effect of climate change could be lack of, let's say, precipitations, rains, the animals of the food will decrease. So people, according to religion, could try to find a reason for why these things happen, and could find in witches, in magic, something like that, reason to explain this. And people could be, I mean, could increase the number of people that can be thought of as the culprit. So this will increase the violence in local level. And
Yes, indeed. Yes, indeed. So basically, the idea was that the rainfall deviation is causing. You can imagine this as a negative income shock to these villages. They will receive less agricultural production. So, and if these are primitive villages whose only source of income is coming from agriculture. There could be two reasons why negative agricultural income shock leads to additional witch hunting. One is, as Emma suggested, when you have a bad shock and a bad luck collectively to the village, you want to find someone to blame. That's the source of belief. I think that we throw someone away, next year things will go back to normal. Another kind of economic root analysis would be that ancient human societies, when they face a collective shock, they tend to throw out the weakest individuals. Imagine you originally 100 people has to. You need the crops, you need the food for 100 people. Now you have the food available for 90 people. Now the truth is you have to sort them out. That's an unfortunate result. So witch hunting is a way to justify that behavior, because there was studies showing that the witches they caught are usually old women without who could not be very productive in the agricultural practice. So can you hear me? Can you hear me well? I received a message saying the voice is not very clear. Yeah, I'll just closer. So that's basically how negative income shock in some human communities could lead to sexual witch hunting behavior. And when we scale up to East Africa in general, there was another study associating temperature anomaly to local violence. Imagine local violence is like violent crimes, more robbery, more murder, more burglary, so on and so forth. You can imagine the relationship could still be economical. Like people facing a negative income shock who can't find a legal job will turn to illegal profession. That's one idea. Another idea may be temperature was affecting human behavior in some way. It's too hot, it affects your psychological stability to some extent, which might lead to additional crimes. And when again scaling up to the whole sub-Saharan Africa, there was a paper looking at cross-country evidence of civil war. So basically, there are a lot of civil wars in this area of the world. A lot of times between tribes, you have different groups of people with different tribes within the country. How likely they engage in civil war is statistically associated with temperature anomaly. So how would you justify that?
In the countries, I mean, in every country there are rich people and poor people. The government is the institution that tries to regulate the access to the resources. If poor people have too much problems, I mean, they are starving, they can endure the things for a limited amount of time. After that, I think they will rebel and think that the reason is because of the bad management of the country. So this can lead to protests and go toward the civil war.
Yes. You can imagine these countries probably they have a lot of times a lack of state capacity when there was a negative income shock and when a large share of their population rely on agricultural. An increased frequency of weather shock is going to make these people vulnerable, and when they're losing their large share of their income and they don't get bailed out in one way or another, they might engage in violent protests turning to war. Or basically, these tribes have already been competing for resources. They haven't been very peaceful over time. It's just you need some. Basically, you had a negative shock. They were competing for resources. They were competing for a smaller pool of resources. Some actions might turn violent. It's also possible. And if you scale this up globally, people are also finding that temperature anomaly is associated to the occurrence of war, not just within country, but also across country, globally. And it appears to be a positive relationship. So we can apply the same rule, the same argument about civil war to country war. It's just could be that countries facing anger from the poorer population had the politicians in order to stay in power might need to shift the blame into another country. These things happen in history over time, right? So you had negative weather shock. A lot of the poor people were losing a greater share of their income. They were angry. They pretty much gave a lot of pressure on politicians, on the government, and the irrational response might be just engaging more. So that was pretty much the evidence collected by this paper. I was trying to say that we had a pretty large share of global population living in areas where their impacts of climate change on their livelihood was pretty obvious. And these were already high complex areas, so you need a spark to light the whole oil barren. So that's something that the global community needs to deal with. And the paper also showed some historical perspectives. So they were showing that starting from a pretty ancient period of time, weather shocks in history. So basically, the sudden rise of temperature, the sudden drop in temperature, the sudden changes in precipitation areas. In history, it was like droughts, sustained droughts, would had overthrown a lot of empires. So this was the way they presented historical climate changes and historical human conflict. So apparently they were trying to, it's just correlational study, they were trying to identify periods of time when the change in temperature was large, or the change in precipitation was large, using this paleoclimate reconstructions based on tree rings or ice cores, all these sort of studies. Across the world, looking at pretty much ancient civilizations, apparently weather shocks could account for this collapse of Maya Empire in Mexico, the collapse of Cambodia, Anglo city-state. In China it had been well studied by at least Chinese historians about how weather shocks lead to the collapse of ancient dynasties. So basically the change of dynasties, the times, and basically the Chinese history was you had a dynasty followed by another dynasty. Before that, it was sometimes a short warring periods. And these warring periods typically coincided with some negative weather shocks, which led to droughts, which led to some protests, uprising, and which led to the invasion from the north, which led to the collapse of empires. And they apply to Europe as well. So Roman conquest, Great Famine, whatever. A lot of historical events. So again, looking at the more recent perspectives or more relevant daily life perspectives, there was a study on, so first it affects temperature, would affect test scores. Sometimes these two be a measure of cognitive ability of people. So when you're taking your math exam in very hot days, during very hot hours, you tend to do worse. That's basically if you took a math exam at 32 degrees Celsius, you're likely to do 5% worse. You will score 5% less than suppose you're doing 22 degrees Celsius. And apparently, there were studies on temperature and profanity in social media. So it's kind of a big data study that scraps the words people bursted out on Facebook, on Twitter. Apparently, when it was hot, people were more likely to burst out dirty words on this social media. And you could relate that to higher crime rates, right? With a previous speaker on temperature anomaly and crime rate. We could have economic forces. We could also have more psychological forces that people were just angrier when it was hot. Was also related to crime rates in the U.S. So we show that normally temperature was associated with local violence in East Africa. Apparently, it was also associated with crimes. I think in this study, their outcome was crime rate of rape in the U.S. I guess the reason was less economical. It's more psychological. It's more just physiological, right? So there has been all sorts of evidence on the negative impacts of temperature, precipitation, on all sorts of outcomes, and the study just goes from all these common variables such as GDP, agricultural production, mortality to less common outcomes to be studied, test scores, social media. It certainly affects a lot of things in our daily life. And taking all these effects together would help us understand the predictable cost of rising temperature, rising variability of precipitation, which would turn again into following some scientific studies, which would tell us about the cause of carbon. Eventually, all these are evidence supporting the cause of corroborating our estimates on the cost of carbon, which is clearly an important policy instrument, policy input for us to decide on the optimal amount of carbon emissions or the optimal equivalent tax rate. So there has been some studies that collect a lot of these numbers and work out the total cost of climate change. Of course, for these studies, you can always raise concerns like there are a lot of factors we haven't incorporated in studying the impacts of temperature, precipitation shocks on economic and social outcomes. But to start with, there was a paper that summarizes all the updates from a lot of studies. I think they are pretty much older papers. The effects ranges. I think in general people don't agree on this. Global warming of 2 degrees Celsius, to be able to take an average, is maybe 2% reduction in global GDP. So to think about the cost of carbon, so basically the reduction in global GDP for rise of temperature of 2 degrees Celsius. Is it large or is it? What's your take on that? 2 degrees Celsius is a pretty large impact, as you can imagine.
We have 2, I think it is quite strange. I mean, not too much, but still there is a positive case if the warming up is only 1 degree. One study says it's increased 2.3% of GDP. Another study says instead that is minus 0.4. So it's
Yeah,
quite.
these are just too small. I think if you disagree on a lot of things, and I think you could probably put more faith on
Yeah.
the papers, where the amendment should be updated. I should update this table. I think it's a little bit old. That's one thing. The other thing would be how do we just add things up across time? Like if we cut emission today by a certain amount, it affects the temperature for many years afterwards, right? If we cut certain level of emission, it reduce temperature next year, the year after, many years after. And these effects could accumulate. A related question would be how do we discount future cost of carbon? So how do we discount, let's say, future benefits of carbon reduction? So if we reduce carbon today, that's a cost today, that's GDP loss today because of additional abatement costs, a loss of jobs, so on. But the benefits gets accumulated over time. It's a one-off shock of reduction in carbon leads to change in temperature. The reduction in temperature leads to accumulated benefits after many years. So a central problem about evaluating the cost and benefits of climate change was to look at was about discounting, right? How do we compare the future benefits to today's cost? Depends on what interest rate, which interest rate we tend to pick. It's going to be a pretty long run phenomenon, pretty long run. So, what's your sense? Will a higher interest rate indicates higher carbon emission tax, or lower interest rate indicate the higher today's carbon tax? So suppose you're doing the math, you're comparing abatement costs today to accumulative benefits after many years, discounted today, the present value of all the accumulated benefits with a higher interest rate indicates higher carbon emission, a higher carbon pickup tax, or the other way around.
1% means the 1% of initial cut, 1%.
Sorry, what was 1% of the interest rate, of discount rate? Like, how would $100 benefits tomorrow be today? Yes. I guess to start with, higher rate means you care more about today than future, right? Means that you will discount future benefits more, which means you care about carbon emission reduction less because it's less important to you in the future. It means you should set a lower carbon tax rate. On the other hand, if you discount the future very little, tomorrow's benefits mean a lot to you. It means that when you're doing cost benefit calculation today, it will prompt you to pick a higher rate in order to lead to a higher reduction in carbon emission today to reap the future benefits. Right. So to illustrate, this is the climate change present value of net benefits. So let's just think about the emission cut as something at short run cost and long run benefits. And that's the present value when you, so assume that the per period cost and benefits is similar across different examples. It's just the interest rate. The interest rate affects present value of future cost and benefits. This would be when you pick 1%, the future benefits much more outweigh more recent cost. If you're doing 2%, it's kind of, they would work together closer. If you're picking 3%, the future benefits appear to be very small compared to the recent costs. And so that's pretty much the power of discounting. Starting from 1% to 3% will make the cost benefit analysis the same problem completely different if we're talking about the decision whose impacts extend over a pretty long period of time in terms of climate change. It's pretty much the time how long will carbon dioxide stay in the atmosphere that basically leaving all these impacts, accumulating impacts over time. So discounting is a problem. It by itself it's a active research field where other people just write all sorts of papers telling us what would be the best rate to pick. We will not go into much details. Maybe it's a good time for a break. Let's have our first break, and I will see you in 9 minutes. Let's meet at 8:05.